All right, so the first thing that I want to do lecture-wise is talk about some old calculus problems. I'm not going to review any calculus methods in particular, but what I want to do is I want to solve what's called an initial value problem. So I'm going to solve an initial value problem. These are problems that you've undoubtedly seen in calculus, but they're going to be very prevalent in our course. So in differential equations. So we're going to solve an IVP or an initial value problem. And that's where what I do is I'm going to give you, let's say, the second derivative. So let's find the function satisfying, let me write this a little bit better. Find f so that the following is true, so that the second derivative is equal to cosine of x minus sine of x plus 4x plus 7, and where let's say f of 0 is 0 and f prime of 0 is 3. Okay, so I want to find the one and only one function satisfying those two conditions. And so what we're going to do is we're going to work backwards. This is the second derivative. We can, from there, integrate once to find the first derivative. So we can think about what's the antiderivative of the function that we have. And that would be sine of x plus cosine of x plus 2x squared plus 7x plus c. And then we're going to use the condition that f prime of 0 is 3. If we plug in 0 to the derivative, so 3 being f prime of 0, leads us to say, well, f prime of 0 on the one hand is going to be sine of 0, which is 0, cosine of 0, which is 1, 0, 0, and c. So this will be 1 plus c. That means that c is 2. And therefore, our first derivative is the function sine of x plus cosine of x plus 2x squared plus 7x plus 2. And then finally, if we anti-differentiate one more time, what happens is that implies that f must have the form, well, the antiderivative of sine would be negative cosine. Antiderivative of cosine is sine. Antiderivative here would be 2/3 x cubed, 7/2 x squared, plus 2x, plus another constant, which I'll call d, just to make sure that we're not confusing our two constants that we have. And then you could plug in 0. So what do we know? F of 0 is 0. So when we plug in 0 here, we're going to get negative 1, 0, 0, 0, 0. That means that d must be 1. And therefore, if I wanted to write this out, which I should, so 0 equals f of 0 means that negative 1 plus d is 0. Therefore, d is 1. And therefore, we can conclude that the one and only one function that's going to fit all these properties is the function negative cosine of x plus sine of x plus 2/3 x cubed plus 7/2 x squared plus 2x plus 1. And that's the only function that's going to have all of these properties. So it's the only function that has this as its second derivative, and it's the only function that satisfies those two what are called initial conditions or initial values. Okay, and so that's the first and easiest type of differential equation that we can solve.